In this video, the periodic table will be introduced. Let's start with the lightest element, hydrogen, and progress up stepwise in atomic number. The next element is helium. Helium is a colorless, unreactive gas. This is followed by lithium. Lithium is a soft, highly reactive metal. Going from there, we have beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then we come to neon, another colorless, unreactive gas, which is followed by sodium, a soft, highly reactive metal, which is followed by magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and then argon, a colorless, unreactive gas, which is followed by potassium, a soft, highly reactive metal. We could keep going like this, but you may have already recognized the pattern. Every time we have a colorless, non-reactive gas, helium, neon, argon, krypton, or xenon, it's instantly followed by a soft, highly reactive metal, lithium, sodium, potassium, rubidium, and then cesium. This concept of reproducible patterns of reactivity forms the basis for the periodic table. The periodic table is based on the fact that the chemical properties of an element cycle through periods, and one can group the elements together according to their chemical properties in a logical and meaningful way. Presented here is the modern periodic table, which groups elements together according to chemical properties. What I'm going to do in the rest of this video is define parts of the periodic table so that we have a working vocabulary for future videos. To simplify things, I'm going to use a blank periodic table and fill in various parts of the periodic table as needed to emphasize various parts of the periodic table. The periodic table is made up of columns and rows. The columns are called groups, and the rows are called periods. A period is just a stepwise progression in atomic number going through the groups until the group repeats itself. A group contains elements with similar chemical properties. For example, those highly reactive metals we started off with all form one group. The simplest way to name groups is based on the first element found within that group. For example, group 8 is sometimes called the iron group, while group 13 is sometimes called the boron group. However, all of these groups have specific names. Hydrogen is fairly unique in that it doesn't fit very nicely into one group or another group. Therefore, we consider hydrogen to be in a group by itself. Group 1, which contains lithium, is referred to as the alkali metals. Group 2, which contains beryllium, is referred to as the alkaline earth metals. Group 11, which contains copper, silver, and gold, is referred to as the coinage metals. Group 15, which contains nitrogen, is referred to as the pnictogens. Group 16, which contains oxygen, is referred to as the chalcogens. Group 17, which contains fluorine, is referred to as the halogens. And group 18, which contains helium, is referred to as the noble gases. If you notice, we skipped large areas in the periodic table. Instead of defining each column in those large areas, we're just going to define the area as a whole. Groups 3 through 11 are referred to as the transition metals. So the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and copper groups all comprise the transition metals. Typically presented at the bottom of the periodic table are two additional periods. The elements in the period that begin with lanthanum are called the lanthanides. The elements in the period that begin with actinium are called the actinides. In addition to these divisions in the periodic table, we can also sketch out broader categories within the periodic table. The elements that are contained in the alkali metals, the alkaline earth metals, hydrogen, and helium are referred to as the S block. The elements in columns 3 through 12 are referred to as D block elements. The lanthanides and actinides are referred to as F block elements. And the elements in columns 13 through 18, with the exception of helium, are referred to as P block elements. Sometimes one will describe main group elements. Main group elements are those that are contained in the p block, the s block, hydrogen, and helium. The elements found in the d block and the f block are not main group elements. To summarize, the periodic table organizes the elements on the basis of chemical properties. Elements with similar chemical properties are placed into the same group. Groups are columns in the periodic table. There are 4 main blocks on the periodic table, the S, P, D, and F blocks, and S and P block elements are called main group elements. In the next video, we will be discussing ionic and molecular compounds.